Welcome back, student. Now we discuss an example based on double integral by converting into polar form. And this example is very simple. As we people already aware that we have already discussed by changing the order of integration already in the previous classes. So, and this is very easy one. Just first we are going to draw a region of integration. So before drawing region of integration, as we people already aware that if the limits containing the variable x, it corresponds to y, and the other value should be x only. Fine. So we have denoted, and here we are not going for order of integration because we are converting into polar form. First, let us draw a region. Okay. So this is y-axis, x-axis, origin, x equal to minus a to plus a. So call it as this is some plus a and this is some minus a. So x equal to minus a is a line parallel to y-axis, which is left of y-axis. So this is right of y-axis, x equal to a, this is x equal to minus a, x equal to minus a. Okay. This is x equal to minus a. So what actually it will calculate? It calculates the area between these two lines. Okay. So now what about this? This is, you just remember, left to right already. Okay, x value stands for left to right. So the lower portion is y is equal to 0. This is y is equal to 0. That is equation of x-axis. It starts from x-axis. So we don't consider the area below this x-axis. So above, this is a lower portion is y is equal to 0. And the upper portion is y is equal to square root of a square minus x square. On squaring on both sides, y square is equal to a square minus x square. You bring minus x square to left side, it will become x square plus y square is equal to a square. It represents a circle with the center at 0, 0. And radius r is equal to a. Radius is a. Therefore, I am just drawing the diagram. Just look at, this is the circle. Okay. It starts from y is equal to 0 to here. So therefore, what is the region of integration is, this is the region. This is the region, or this is the integration, this is the area we need to calculate. Okay. So therefore, so how to calculate this? Actually we are calculate this double integral into polar form. Okay. Look at what is the first step towards this is, first we have to substitute x equal to r cos theta, y is equal to r sin theta. Okay. On squaring and adding, x square plus y square becomes r square cos square theta plus r square sin square theta. So r square is common, you will get cos square theta plus sin square theta. So cos square theta plus sin square theta is 1. Therefore, you will get just r square, or x square plus y square is equal to r square. In the given example, the value of r is a. Already I have mentioned. Okay. So then just look at, I am convert again x equal to r cos theta, y is equal to r sin theta, x square plus y square is equal to r square, and we need to substitute dx dy is equal to r dr d theta, r dr into d theta, dx dy is substituted as r dr into d theta. This is Jacobian into dr by theta. Jacobian value is, you get r. So therefore, and look at, you are converting x and y in terms of r and theta, and look at the value of a radius. Radius means a, okay. The radius means the value a, and the angle, just look at the angle. This is 0, this is pi by 2, this is pi. So therefore the theta varies from where to where? 0 to pi. Okay, 0 to pi. So you can write theta varies from 0 to pi. So therefore the new integral becomes, integral runs from either write first r or second theta, or first theta or second r. You know that theta varies from 0 to pi and r varies from 0 to a. And look at this square root of x square plus y square is taken as r square, right? And dx dy is r dr into d theta. Okay, fine. Now just look at, okay, now this is equal to integral theta runs from 0 to pi, okay, and r runs from 0 to a. Square root of r square is r into r is r square again, r square into dr d theta. So first we have to integrate with respect to r, okay, then with respect to theta. So theta runs from 0 to pi, okay, 0 to pi. So let us, integration of r square is r cube by 3 between the limits 0 to a d theta. Okay, fine. So which is equal to integral theta runs from 0 to pi. Substitute upper limits, take 1 by 3 outside because it's a constant. Substitute upper limit, r is a cube minus lower limit is 0, cube is 0 into d theta. So this is 1 by 3. A cube minus 0 is a cube. A cube is a constant. You can take a cube also outside. You will get theta runs from 0 to pi. So you will get 1 into d theta. Integration of 1. So which is a cube by 3 times of integration of 1 with respect to d theta is theta and varies from 0 to pi. Substitute. This is a cube by 3. Upper limit is pi minus lower limit is 0. So the answer is a cube pi divided by 3. So this is the value of the integral by using or by converting the given double integral into polar form. Thank you so much for watching. We will meet in the next video. Please subscribe my channel for more videos. Please like it and share it, and if you find any difficulty while understanding, please feel free to comment. Thank you so much.